Hello, and let's talk about Windows deployment services. Over the course of several semesters, hopefully we've gone through a lot of these components, but today we're going to go over the big picture and the details of how everything works together. So we're going to answer the question, what happens when we boot a computer with a blank hard drive in the CIT lab? The CIT lab here at blinn.edu, we've set it up so that we can install all of these computers for all the students when we have different classes. So what happens? And remember, all of this we've kind of talked about before, hopefully, and we're going to go through it and put it all together. 5 hosts are involved in this process, the entire lab. Well, in our case, actually, not so many. First, we have the client computer. This is the computer that needs the operating system. It's got a hard drive, it has nothing on it. We're going to need to talk to a DHCP server, Dynamic Host Configuration Protocol. We're going to need to talk to a DNS server, Domain Name Services. We're going to need to talk to a Windows Deployment Server, or a WDS server, and we're going to need to talk to the domain controller. So that's 5 different services in general that we're going to work with, or 5 different hosts. However, in our case, our DHCP server, our DNS server, and our domain controller are all on this same physical server. When we installed a Windows domain controller, it requires DNS server. That's how it works now down in Active Directory. And we also added a DHCP server to that because those are the 3 components that we almost always need to get started with. So we need all of these services, and we're going to talk about them, how they work together. Okay, here's a slide of the big picture of what all is going on. We're going to go through the details in a little more as we go on, but this is going to start out with, hey, what all happened so that I could get an operating system? First, your computer is going to boot to a DHCP server. Why does it do that? Well, your computer can't really boot to the DHCP server. Your computer is going to boot up. It is going to have a PXE boot, which stands for pre-execution environment, that says, hey, I don't have anything, I don't have any IP addresses, I don't have any operating system, I don't have anything. So we're going to go to a DHCP server, get an IP address, and get some other information. Part of the information we're going to get is a reference to a Windows deployment server. Well, we don't have an operating system, and we just did a PXE boot, so it knows that we're probably going to need more going on here. So our Windows deployment server is going to say, hey, I see you need an operating system. I'm going to give you one for now in memory. It's not going to be anywhere else. So far we have IP addressing in memory. We have a Windows deployment in memory. But if we turn off our computer, nothing was there. It's all just in memory. It's called a stub operating system, and it's just enough to get us going so that we can do something else. Part of the things that we were given is names of these servers. So we're going to have to reference our DNS server that we got from DHCP to figure out the IP address of the names because we're communicating on an IP network. So we're going to have to do a little bit of that, and we're going to talk about where that comes from. So now that we have the stub operating system, it's going to give us a list and say, hey, what do you really want to do? Now that I've got everything in memory, I can communicate what's going on here. And that's when you get the menu options of what do you want to install. This also comes from the Windows deployment server, but we set it up where you have a lot of options. You figure out what you want, which one you want, Windows 10 probably, or Windows Server 2016. In our case, we're on an Active Directory domain. So we're going to need to reference the domain controller to make sure all this is okay. Did we allow you to do this? Is your machine okay to do this? Now in our case, we actually said everybody could do this because when you're a student the first time, we don't know who you are when you're installing in the lab. And because we have so many students, we don't want all of this in Active Directory either every semester. So our domain controller is going to authorize this, but it's not going to do much more than that. And then the deployment server, who now has permission, is going to give us all of our information, and it's going to install our new OS. The first host we're going to talk about is the client computer. The client computer must support the PXE boot. Not everything does across the board, but nowadays, yes, it does. So we need it supported in the BIOS, and that could mean the old school legacy BIOS or UEFI. So the BIOS supports a PXE boot. The network card has to support a PXE boot, which might be a separate network card. In our case, it is, or it could be an onboard network card. And we have to configure it to boot to NIC, and that's in the BIOS configuration, so we can allow it to boot to a network interface card. We obviously let it do all of this stuff, and that's what would happen in the real world. You have to have all of these working together. So once we get our client computer going, we boot up, we tell it in the BIOS to boot from the network card. Like I said, we might use F2 or F8 one way or the other and say boot this from the network card. The network card doesn't have anything. Not only does it not have an operating system, it doesn't even have an IP address to communicate on the network. So the first thing it's going to do is talk to a DHCP server. It's going to do a broadcast and say, hey, I need an IP address, and eventually the DHCP server is going to give it all sorts of information. So how does this work? Here's the DHCP process in Wireshark. So when you first boot up, and this could happen whether you have an operating system or not, but if you need an IP address, the first thing the computer is going to do is a DHCP discover, which is in the top window. A DHCP discover says, hey, it's a broadcast from 0.0.0.0, which simply means me, so anyone is me, I don't know who it is, but me, to 255.255.255.255, which is the broadcast. It's going to say, hey, is anybody out there a DHCP server? Where do broadcasts go? Well, they stop at a router. So this all happens on your LAN, on your local area of network. If your DHCP server is on a different network, this message isn't going to get there. So what you're going to have to do is have a relay agent, a DHCP relay agent on your local network that says, if I see one of these DHCP discover messages, I will forward it on to the correct machine. We don't have to do that. Ours are all local. So we send out this message that says, hey, is anybody out there a DHCP server? And you see in the lower hand, then we get a DHCP offer. One of our servers says, hey, yeah, I'm 192.168.2.1, and I'm telling the world that I'm willing to give an IP address to the machine that just requested it. And you see that we have a transaction ID so that we don't get mixes up in conversations with DHCP. It knows that this is one conversation. It says, here's what I'm going to give you. Now you might ask, why did it broadcast it when it could tell who we are? Because even though we're using IP addresses, underneath that we're using MAC addresses. So when we broadcast to 255.255.255.255, we really went to ff.ff-ff-ff-ff-ff, which is the MAC address broadcast. And when the DHCP server replied, it used its own MAC address. Well, we know its MAC address, and it knows our MAC address at this point, but it's not going to tell us directly. It's going to announce to the world that it's giving us an offer, so that any other machines are going to see that too. And we're going to reply back again from us, 0.0.0.0, for a broadcast to say, yes, I want that MAC address, I want that IP address that you just offered me. So just in case more than one DHCP server offered us an IP address, they'll know who we're talking to. So we've said, yes, we want yours, and the final is a DHCP ACK. The server sends us an acknowledgement. Yes, you have the IP address, and by the way, there's probably a bunch of other stuff that you need from me, and I'm going to give you that too. So remember, DORA says it at the top, D-O-R-A, discover, offer, request, acknowledge, and that's how it's always going to work. That is a DHCP process. Now, on the other hand, if you already have an IP address and you're just renewing it, you're just going to do the request and the acknowledgement. But in our case, we need something because we don't have it. So here is our DHCP server and the options we put in. Now, when we first set up our DHCP server, what we're going to have to do is tell it what is our IP addresses we're giving out. And in our case, our scope is 10.38.0.0. So that's the range of IP addresses. And that's a /16 network, which is 255.255.0.0. We all recall IP addressing and subnetting. And then we're also going to provide some scope options. Now normally we would give the router, because that way we can get it out of the network. We give some DNS servers so we can resolve names to IP addresses. And our domain name helps out with some things. But in this case, we're talking about what happens for the Windows deployment server and the Pixie boot. So we're going to have to say, well, if you don't have an operating system, and I gave you all this information because you need an IP address, you probably need something further than that. We're going to have a Pixie client, we're allowing that. The boot server host name, so what server are we going to go through to get information? Subaru.citlab.blinn.edu, go there, and that's going to give you some more information. And you're going to use a boot file to get your boot process working. We put a default in here, and that is boot.wim. Now this is the operating system that it's going to install in memory for us. We could have made a menu option to begin with, but then we'd have two menu options, and the first one's loaded in memory and erased, so there was no point. So boot.wim is actually Windows 7 in our case, and it's just enough to get us installed, and that's where we're going to go from there. Now the DNS server had to provide a little bit of information. Well, we told it could go to Subaru to get this information, but where the heck is Subaru? Well, luckily at the same time we got the DNS information, and so we talked to our DNS server and asked for the resolution, and we get that going. And at some point we're going to need to know the domain controllers to get approval to do the full installation. Not for this little stub operating system, but the full installation we'll need approval for. So we need to know who the domain controllers are. So here's how we find who the domain controllers are. Well, I can't request the name of the domain controller. I don't know the name of the domain controller. I'm just going to tell DNS that I need a domain controller. And if we have Active Directory integrated with DNS, which is required now with Microsoft, then we're going to have these records. We're going to go into the citlab.blinn.edu domain zone. We're going to go to _TCP. And there's going to be some other records, _GC, which means global catalog, Kerberos, which is the authentication type, the Kerberos password, and LDAP, which is the database type. And all of these are SRV records. SRV is a service record, or technically service location. It's going to say, where is this service? You asked for a domain controller. So you asked for LDAP, and where is that? That's on Viper or Lotus. So now we know where to get there, and then we also have our records in CIT Lab, which is going to tell us how to resolve Viper and Lotus. Windows Deployment Server. What's the whole point of where we were going with this? In the Windows Deployment Server, we have two different files. We have a boot.wim file, that's a stub operating system file that we just loaded into memory, and we have an install.wim file, which is the full installation of what we're doing. Okay, and we're going to provide these menus from our Windows Deployment Server. So take a look at that. This is our Windows Deployment Server. We have Subaru, which we just referenced, now we go. Install images, and our install images in the CIT Lab. What are all our install images? Well, when you boot up and you get the menu, see them. We have Windows 2016, Server, Data Center, Core, Not. You don't see these Windows Server 2002. Why not? Because, as it says, they're offline. We have them. We just said that you don't need them anymore, and we'll see if we need them later. Or Windows 10. So this is the menu. Now I didn't open up boot images because we only have one in there, and that's the Windows 7 boot.wim file. Now where do we get these boot.wim files? Well, from the operating system deployment media. So if I have the ISO file, there is a support directory in the ISO file that has an existing boot.wim and install.wim file. And all you do is copy them over, and inside it's going to show all of these different options of what you're installing. And last we have our domain controller. The domain controller, Windows Active Directory domain controller, provides authentication for all of this, or I should say it can provide authorization for all of this. In our case, we're a little flexible because we're a lab and because we don't know who's logging in and doing all of this. So it's not going to ask you any questions in order to get the boot.wim installed, but once you try to actually install the operating system onto the hard disk, that's when you're going to get asked for a username and password that has approval to do that, and we all use the student password for that. So that's all the domain controller has to do in our case. It could do a lot more. We could add all of these computers to the domain. We could add users to the domain. We could pre-name all the machines. Not doing any of that in the CIT lab, but we still need the domain controller to approve something because we're in a domain. And that's everything in the process. Here's all of the acronyms that we talked about. And after that, just do your labs. So hopefully that went through everything at once, and now we know how this goes.